10.4, folks. Make sure you go up top and look at the property of logarithms. There's a bunch of formulas. Have them all written down to reference. I'm just going to sort of jump into it. So use the properties of logarithms to evaluate. So 218 log base 4 of 1. We sort of did this already. We're trying to figure out what this is. So you could just kind of say, let's let it equal to x. 4 to what power is that? So just rewrite it from logarithmic to exponential. 4 to the x is 1. And we know that anything to the 0 power gives us 1. Okay. Part B, log base 8 of 8. So once again, like we did in previous chapters, I'm just going to set it equal to x. And then say, go from logarithmic to exponential. 8 to the x is that. Remember how we did that? Boop, boop, boop. 8 to the x power is 8. You just look at that and you say, oh, obviously it's the first power, so x must be 1. So maybe say 8 to the 1. Bases are the same, so exponents have to be the same. Okay. Ugh, 220. Okay, 220. They already start doing a crazy formula. 3 log base 3 of 6. Now I can explain this formula later, but for right now I'm just going to borrow the formula from up top. They have this property. It says a log base a of x is just x. A log base a is just x. Okay. So you see how the a's look like 3's? And that's the 6 is the x. So this, so 3 log base 3 of 6 is just 6. Huh? We're just using the formula. So right now you just have to have complete faith in the formula. So you're like, well, this doesn't make sense. I can get the answer 6, but that makes no sense. And I would say, good. Don't worry about it making sense yet. We'll learn something later so I can prove this formula. But right now, let's just go with it. Okay. Sure. So then that was 220A, 220B, log base 2 of 2 to the 7th. So this one we can kind of use our old technique. Let's just set it equal to x. 2 to this power is that. 2 to the x is 2 to the 7th. Oh, so that means bases are the same. Exponents must be the same. So x must equal 7. Okay. Hubba, 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 hubba. Da. Okay. Okay. And then, moving on, 228. Use the product property. Okay, so if you look at your rules, the way logarithms work, let me write it down. Where's those rules? Rules. Scrolling up. Properties of logarithms. So we're going to use this idea. Log base a of m times n is just going to be log base a of m plus log base a of n. What? Just go with it. So within a logarithm, multiplication breaks up into addition. And then you can also see the next formula we're going to use. I might as well, since I'm looking at the properties. So the next formula we're going to use, so the next 2 or 3 problems we're going to use this formula. Multiplication turns into addition. And by that, similar logic, division must turn into subtraction. Log base a of m minus log base a of n. Notice with division, the guy on top is positive, the guy on bottom is negative. Okay, let's do some problems. Logarithms. 228. Log base 4 of 6x. And they just want you to break it up. Okay. So that's just, they're being multiplied, right? Put a little dot there. So that's just log base 4 of 6 plus log base 4 of x. That's it. 230. Log base 2 of 32xy. Oh, so there's three things, a 32, an x, and a y. So I'm going to get three things being added. No big deal. Log base 2 of 32 plus log base 2 of x plus log base 2 of y. Are we done? Well, can anything be simplified? I guess I ignored log base 4 of 6. 4 to any power doesn't give me 6. But log base 2 of 32. 2 to what power gives me 32? 2 to the 5th. So log base 2 of 32 is 5. Whew. Log base 2 of x plus log base 2 of y. And there's our answer. Okay, now we are going to use this formula. So using this formula for something like 234. Let's see if I'm getting this on the page. 234 says log base 3 of 3/8. So log base 3 of 3/8, see how that guy's on top, the 3, the 8's on bottom? So that's log base 3 of 3, and then the 8's on bottom. Division is really subtraction. Log base 3 of 8. Okay, is 8 a power of 3? No, so that's fine. Is 3 a power of 3? 3 to what power gives me 3? 1. So 1 minus log base 3 of 8. Oh my. Oh my. Okay, 236. Log base 4 of 16 over y. Okay, division turns into subtraction. So that's log base 4 of 16, because it's on top, and then the guy on bottom will be minus. Minus log base 4 of y. The 4's and y's look similar. Arg. Give the y more of a little tail. Okay. So that's not going to... 4 squared is 16. 4 to a power of 16. So this is just a 2. Log base 4 of y. Okay. Remember, log with no number is log base 10, and ln is just log base e. So let's do 240. Ln e cubed over 3. So that's just log base e. So that's just ln of e cubed minus ln of 3. Top guy minus the bottom guy. Division is just subtraction. And ln of, isn't that really a little e? This is log base e, so you might want to think of a little e right there. E to what power gives you e cubed? 3. Okay. So notice how we were expanding that. Okay. Now, is that what they wanted us to do? The sum of logarithms. Okay. Yeah. Okay. Let's see. Now, ooh, the next idea. 242. 242. So we have that one rule up top. Scroll up. It says, what does it say? Log base a of m to the p is equal to p log base a of m. So go up to properties of logarithms. It's that last one in that gray box. Okay. Oh! Didn't mean to do that. Okay. Equal to p log base a of m. Okay. Rewritten. Nice and pretty. Confusing formula. Basically, this one's easy. 242. Log base 3 of x squared. So the whole reason logarithms were invented in my opinion, was so we can bring the exponents down. So basically, whenever you have a log of something, all the exponents just come out in front. So that's this whole idea. The exponents come out in front. Log base 3 of x squared. That little 2 comes out in front. 2 log base 3 of x. Oh, that's easy. Okay. 244. Log of x to the minus 2. Oh, exponents come down in front. Negative 2 log x. That's easy. I know. Let's see. Okay, 250. They want us to expand. Okay. 250. Log base 5, 4, x to the 6, y to the 4. So now we're going to use all of our rules. All those exponents are going to come down in front. Those three things are being multiplied, so we're going to turn them into addition. So just a couple steps. You could probably, once you do enough of these, you'll realize they're pretty easy. Log base 5 of, those three things, I'm going to break them up. 4 plus log base 5 of x to the 6 plus log base 5 of y to the 4th. Multiplication is really addition. Okay? And now, all those exponents come out in front. Log base 5 of 4 plus that 6 comes out in front, 6. Log base 5 of x plus that 4 comes out in front. Log base 5 of y. Ta-da! No big deal. Let us try. Let's do 252 really quickly. Log base 3 of the square root of 2, x squared. Square root of 2, that radical symbol, can we turn that into an exponent? So isn't that log base 3 of 2 to the 1/2? Okay. And then, put some parentheses, it looks prettier, right? So this is going to break apart. Log base 3 of 2 to the 1/2 plus log base 3 of x squared. And now exponents come out in front, so 1/2 log base 3 of 2 plus exponents come out in front, 2 log base 3 of x. Oh my. Okay. Problems are getting better. 253, 254. 254. Log base 3 x y squared z squared. Okay, those guys are on top, that guy's on bottom. So log base 3 of x plus log base 3 of y squared, because they're positive because they're on top, downstairs, division, subtraction, minus log base 3 of z squared. Now, let's bring all those exponents out in front. This one's fine, log base 3 of x plus exponent comes out in front, 2 log base 3y minus exponent comes out in front, 2 log base 3 of z. Done. Do they get more interesting? Easy. Remember, square root is just half power. Cube root is just third power. Okay, let's just jump to 260. Am I going to need more room? Oh my. Okay. I'll try and fit it all in here. We shall see what happens. Log base 2, 4th root of 5x cubed 2 y squared z to the 4th. isn't fourth root, isn't fourth root 1/4 power? So let's rewrite this as log base 2, all of this to the 1/4 power, 5x cubed 2y squared z to the 4th. And then let's do that little 1/4. The 1/4 multiplied by each power. So that's going to give me log base 2, 5 to the 1/4, x to the 3 times 1/4, 3/4. Downstairs, 2 to the 1/4, y squared. What's 2 times 1/4? 2/4? 2/4. 2/4 reduces. 2/4, 1/2. Z to the 4 times 1/4. What's 4 times 1/4? 4/4, which is 1. Okay, so I'm just multiplying each exponent times that 1/4. Log base 2, 5 to the 1/4, plus upstairs stuff, right? Is positive. Log base 2, x to the 3/4. Downstairs stuff, subtract. Minus log base 2, 2 to the 1/4. Minus log base 2, ran out of room, y to the 1/2, minus log base 2 of z. Oh gosh. Okay, so that's going to give me, that's fine. Oh, the 1/4 comes out in front. 1/4 log base 2 of 5. Okay, that's the first one. Next one, the plus, the 3/4 comes out in front. Log base 2 of x. Okay. Oh my god, log base 2 of 2 to the 1/4. This one cleans up. The 1/4 comes out in front, minus sign, 1/4, so the 1/4 comes out in front. Log base 2 of 2. 2 to what power gives us 2? 1. So log base 2 of 2 is just 1. So the 1/4 comes out in front. There's a minus sign. The 1/4 comes out in front. And then log base 2 of 2. 2 to what power gives us 2? Just 1. So you can put a 1 here if you want. Minus. Okay. Oh, the 1/2 comes out in front. Log base 2 of y minus log base 2 of z. Ta-da! Oh, that's it? Yeah, no problem. Okay, so that was 10.4.